To get started, let's make sure that we understand what's going on in this argument. We have a single premise and it's a horseshoe sentence. If A, then both B and E happen. And the conclusion is also a horseshoe sentence, and it claims that if A happens, then E also happens. So really almost what premise one is telling you, at least in meaning, the conjunction of both these sentences. And so, of course, our conclusion does validly follow. Now, of course, understanding the argument is not quite the same as constructing the proof because, well, for example, there's no rule that just lets us this, Even so, understanding what's going on does give you some clues as to how to proceed. We only have one premise. Its main operator is a horseshoe, and so we're limited to the horseshoe replacement rules. And out of those, notice that exportation is not an option. For exportation to be applicable, we need the conjunction to be in the antecedent position. However, in our premise, the conjunction is in the consequent position, and so we cannot use exportation. Transposition is an option, going to get us anything. And so in many ways, we are stuck with implication. IMPL, for short, allows us to shift between horseshoes and wedges. And when we do that, we take our horseshoe, so in this case, it's A, hook, B, and E. And what the rule tells us is the new sentence is going to take the erstwhile antecedent and negate it. So that's going to be A. We're going to turn the horseshoe into a wedge. And then we're going to copy over the consequent or the erstwhile consequent as it was. And of course, that's indeed what we get in line 2. Now, while line 2 doesn't maybe look like it's any closer to our conclusion, in fact, maybe even a little further away because we've lost that horseshoe, what line 2 allows us to do, however, is distribute that tilde A. Since we're starting with a wedge whose right-hand side is a conjunction, we're looking at this bottom version of distribution. So now, as a way of both understanding and remembering distribution, remember what it is that you are distributing and what it is, the left-hand component and the operator, P or gets distributed across the Q and the R. And so what does that look like visually? So if you have a wedge and a dot, the new sentence is going to have a wedge and then a dot and then another wedge. So wedge dot goes to wedge dot wedge. The conjunction will be your main operator. And then again, you're distributing the P wedge across the Q and the R. So that's going to look like P or Q and P or R. So in the context of our proof, tells us to distribute that tilde A over the B and the E. So again, we get wedge dot wedge. And this time it's going to be tilde A distributed onto the B or over to the B, and then tilde A wedge distributed onto the E. So that means that line 3 is going to be distribution. So dot wedge dot, and we're distributing the tilde A or over both the B and the E. That's going to be line 2 distribution. And this new sentence does get us a little closer to our conclusion. Remember, we were looking for the A and the E by itself. In the right-hand conjunct now, we do have an A and an E. And because it's the right-hand conjunct, we can get it on a line by itself by using simp. And IMPL is your friend to move between horseshoes and wedges. Since we have a wedge, we're going to be going this way with the replacement rule. And when we go leftward, what we're doing is we are taking the left-hand disjunct without the negation, replacing the wedge with a horseshoe, taking our consequent as is. So in the proof, that's going to look like A horseshoe E. And just to double check it, we have tilde A wedge E. The rule says take that left-hand disjunct, leave a negation behind, and just take the disjunct, make it into and then copy over the right-hand disjunct as is. So we get A hook E. That's going to be implication on line 4, and that's our desired conclusion. And so we're done with the proof.